Hello class, welcome to our first lesson in section 10.4. This deals with compound events. We're going to be looking at some things kind of with some locks and combinations and things like that today. So you want to pay attention to those ideas, especially with the password idea, and then we'll make sure we're clear about today's homework as well. Before we get too far into everything, I just wanted to review a few things about surface area and volume of a cylinder. Remember, the volume of a cylinder is area of the circle times its height of the cylinder. So this would be pi times the radius squared. Remember, if the diameter is 4, the radius is 2, so 2 squared is 4, and then times 11 would be 44 pi. Notice that it said write answers in terms of pi and then find the decimal. I just wrote the answer in terms of pi. I can trust that you can multiply by the pi button on your calculator. And remember, volume is the unit cubed. Surface area is 2 circles, so 2 pi r squared. So that'd be 8 pi, because 2 squared is 4, times 2 is 8. Then 2 pi r times the height would be the circumference of the circle times its height of the cylinder, and that would be 44. And together, 8 pi and 44 pi make 52 pi. And again, that's square miles because it's an area question, not a volume question. The other thing is some of you are noticing really the units here. This is a pretty insanely large cylinder if you had to think about making it. So just something to think about with the units as well. Okay, if you've ever seen combination locks, there's different versions. So one version is like the spinning dial where you have to just match the 3 numbers up. Okay, so each wheel has numbers 0 through 9. And so the lowest possible number, if you just think about a 3-digit number, would be 000. So 000 would be the first one. The greatest 3-digit combination would be 999. And that leaves me with 1,000 options because you think it'd be 999, but that wouldn't include 000. So add that in and we have 1,000 options total. Another way to look at this, which is probably what you're going to be using more often, is using what's known as the fundamental counting principle. You're going to look at more of that later today yourself, and then tomorrow, the next lesson as well. But essentially what's happening here is there's 10 options for each wheel because it's the number 0 through 9. So there's 10 locations on each of the wheels. And so it's 10 times 10 times 10. And then you multiply those together and you get 1,000. This is a lot faster than just, say, thinking about it to try to figure out the number of options. So it just uses this counting idea where you multiply the groups together, and then that will tell you how many options there are in total. The next one is a combination lock. Maybe you see one of these. A lot of these are on lockers and things like that. They're numbered 0 to 39. Now remember, you have to go right and then around and then left and then back to the right. How many combinations are possible? Well, 0 to 39 has 40 options because you got to include 0. So it's 40 times itself, or 40 to the third power, and you end up with 64,000 options. Compare that with the first one. There's only 1,000 options for this first version of the lock. Now there's 64,000 for this version. The next lock is similar to the first one, but you'll notice it has the wheel 1 is 0 through 9, then A through J, K through T, and then 0 through 9 again. We already know the 0 through 9 has 10 options. What's funny here is the A through J is also just 10 options. It just happens to be letters instead of numbers. So it's really the exact same combination lock as the first one, but there's one more option and one more wheel, excuse me. So it's 10 to the fourth, or 10 times 10 times 10 times 10, which would be 10,000 options. So of the 3, the hardest one to figure out would be the second one, for probably 2 reasons. One is you got to make sure you know how to open the lock correctly. And number 2 is it has the most numbers to look at in terms of the each location, since there were 40 numbers for each case, whereas these others only had 10 options for each case. Using that same idea, we can talk about passwords, much like a phone password or any type of password that you're looking at. So if your password must have 4 digits, so remember digits is the number 0 through 9. So if you're not sure about that, the word digits is 0 through 9. And there's 10 options for each, so this is just 10 to the 4th, or 10,000 options. If you increase this to a 5-digit passcode, it's 10 to the 5th, which would be 100,000 options. More secure password would be the one that has 5 instead of the 4 digits. That would be the one that you want to pay attention to. Now let's change that to capital letters. So if there are 6 capital letters, I'm using the standard English language for this, so the 26 letters of that alphabet. If it was a different language, it would have a different amount of options. But it would be 26 to the 6th power because it's 26 each time. Everything can repeat itself. There's no issue with repetition. So 26 to the 6 would be just over 3 million options. Now let's change that to an 8-digit passcode that's digits or capital letters. So there's 10 digits, 26 capital letters. So that means in each location then, there's going to be 36 different options that are possible. This changes everything greatly. Notice we went from 10,000 options just for a 4-digit passcode to 5 digits has 100,000. If we picked 6 capital letters, we got 300 million. If we change it to digits and or capital letters, it's 36 to the 8th power, which is over 2 trillion options. So this is why many of your passwords nowadays has to be 8 symbols long. It has to have a symbol of some type. It has to have a letter. It has to have a capital letter. It has to have a number. It has all these stipulations because it makes the probability of guessing it even harder. And so most likely in this case, people aren't guessing your password. They probably know it if they do, because there's 2 trillion options, almost 3 trillion different options that you could choose from. Just digits and capital letters. That doesn't even include lowercase and or symbols. Okay, let's say a school computer requires a password that's 5 spaces long. It can consist of lowercase letters and numbers. So this would be the same 36. The lowercase would be the exact same as the capital letter and the digits. So there's 36 options for each, and then raise that to the 5th power or times itself 5 times. One thing you may want to double check is make sure you're able to do that to the 5th power on your calculator. This says that a hacker has a program that checks 800 passwords a minute. What's the greatest amount of time that will take the program to guess your password? Well, first off, there's 36 to the 5th passwords, and then I just divide by 800 to say how many minutes it takes. It takes about 75,000 minutes. Now, that number is a lot, but let's put this in perspective. Dividing by 60 would figure out how many hours, and it's just around 1,200 hours. Divide that by 24, you get 52 days to guess your password correctly. And that would be if it took all the options and guaranteed it. What this probably means is if someone hacks into your account, it's not just a random guess. They probably figured it out somehow. They illegally found it somehow on a server somewhere and hacked that server. Maybe they figured out, the type of password that you're using, things like that. So, rule of thumb: make sure you have a good password. Make sure you understand what that password is. Don't make it too obvious, and use a combination of different letters, numbers, etc., and symbols. And you should be able to kind of curb some of those hacking issues. Okay, your homework today has 2 pieces. First, you've got section 10.4, which is the normal stuff, 1 through 8, and 31 through 33. Questions, I think 6 through 8 or 5 through 8, I can't remember exactly off the top of my head the numbers. But this middle section of this first group, you have to use the examples and definitions to help you. So there's examples in your book, examples 1, 2, and 3. You should be able to look at those and figure out what it means to do that. Please take a minute and actually look them up. Don't just say, teacher, I'm not sure how I get number 6. I don't know what this question's asking. Look at examples 1, 2, and 3. They spell out very clearly what you need to do on those different situations. And to help with that, you also need to write down for your homework the definitions of sample space, fundamental counting principle, and compound event. Those 3 things should help you as you're going through your homework. But you want to make sure you write those 3 definitions down and make sure you understand them, knowing that they're used in questions like 1 through 8, especially the latter part, like 6 through 8 for sure. But please make sure you take some time, struggle with this a little bit to make sure you are looking at those definitions correctly, and see if you can figure out how to find those answers. The last questions has some review questions with angles, I believe. It'll say what section that's from, and you can look back on that section in order to make sure you remember how to write an angle. Remember, the vertex has to be the middle letter of the 3 letters that are used to write an angle. Have a good day, everyone.